So in this video we are going to see the continuation of the introduction part, and in the previous video we saw about what is the data structure, need for the data structure, and in a classification we saw what is the primitive data structures, non-primitive data structure, then linear data structure, static data structure, and in a static data structure it is a array is a example for the static data structure, and briefly we saw about the array. And now we are going to see about the dynamic data structure. Okay, dynamic data structure. So in a dynamic data structure the size is not fixed. Okay, so the size is not fixed here. It can be randomly updated during the runtime. Can be randomly updated during the runtime, which may be considered efficiently concerning the memory, space, and complexity of the code. Okay, so the best example for this data structure is queue and stack. The next one is a linked list. So linked list, so it is also one of the data structure. Okay, it is also one of the data structure. So linked list, it is a linear data structure in which elements are not stored at the contiguous memory location. So array means in an array the elements are stored contiguously. So for example, if we have taken the array A of 5, so the size of the 5, right? So in a memory space what we are doing, we are allocating the 5 spaces for this particular array. Okay, for example the values are like this, and if the memory is starting from the 100 means, so if it is an integer the size is 2 in a memory, so 100, 102, 104, 106 and 108. So in contiguously the memory will be allocated for this particular array. And if you consider the linked list means here the elements are not stored contiguously, so it will be randomly allocated. Okay, so here, so the definition for the linked list is, a linked list is a collection of data element whose order is not given by their physical location in a memory. Okay, and here for representing the linked list we are using the node. Okay, so this is the node, and this node is divided into the two parts. Okay, the node is divided into the two parts. So this part, the first part, it contains the data. Okay, so the first part contains the data. Okay, so this is the node. Node is divided into two parts. So the first part contains the data, and second part contains the address. Okay, so it is a pointer to the next node. Okay, it is a pointer to the next node. So here data may be any type of data. Okay, so it may be an integer or a character. Okay, it may be integer or a character or a boolean value point. It is maybe a float or double value, and here address, it denotes the pointer to the next node. Suppose if it doesn't have any next node means it will be the null. Okay, if it doesn't have a next node means it will be the null. So this is the structure. This is the structure of the linked list. Okay, so this is the first node. It will be pointed to the head. Okay, and you can see this link. So it is what it is denoting is, it is connected with the next node. Okay, so it is a next node. So here and in the last node there will be the null. So it denotes that it is the last node of the particular linked list. Okay, and the characteristics of this linked list is it will use the extra memory to store the link, right? So it required to store the data, it required memory to store the data, as well as it required memory to store the address also. And during the initialization of the linked list, there is no need to know the size of the element. Okay, so here size is not a mandatory, but in array we need a size. And linked lists are used to implement the stack, queue and graph concept. Okay, and the first node of the linked list is always called as the head. So this is the first node, it is always called as the head. and the next pointer of the last node always pointed to the null. So if it is, this is the last node, okay, so this is the last node means, so the pointer will be denoted as the null. So the meaning is after this particular node there is no other nodes. And here in a linked list, insertion and deletions are possibly easy, okay, and each node of the linked list consists of pointer which address to the next node, okay, and linked list can shrink or grow at any point in a time easy. We can able to expand or we can able to reduce the size of the linked list. And if you see the operations means, we can able to initialize the linked list, then insert the element, delete the element, and if you want to search the element means we can able to do, then we can able to update the element, then traverse and reversing the linked list. Then application of the linked list is it is used to implement the stack and queue concept. Then it will perform the arithmetic operations, and it is used for representing the sparse matrix. Then it is used to use in the linked allocation of the files. Then it will help in the memory management system. Then it is used to perform the undo operations. Then links are used in the software development where they indicate the correct syntax of the tag. And in a linked list you are used to display the social media feeds also. And if you consider the real-time application means, it is used in the round-robin scheduling to keep track of the turn-in multiplayer games, okay, and same time it is used in the image viewer. So previous and next images are linked, hence it can be accessed by the previous and the next button. Then it can be used in a music playlist, so songs are linked to the previous and the next songs. Then next we will see about the stack. So the stack is also the linear data structure, so that follows the particular order in which the operations are performed, okay, and it will work in the concepts of first in first out concept, okay. It will work in the first in first out concept. So for example, consider this as a stack, okay. So if you are entering the data like H, E, L, L, O, so I have done the insertion, and here the insertion process we will call as the push, and the deletion we will call this as a pop operation, okay. So now we have inserted the 5 element, and if you want to do the pop operation means we can't pop the H first. So what is as the top? So this is the top position, okay. Whenever again I will say, so initially the top will be 0, okay, initially the top will be 0 or minus 1, okay, 0 or minus 1. So if it is a minus 1, consider it is a minus 1. So if you are inserting the value, I am doing the push operation H. So what will happen? The top value will be increased. So the top position is 0 now. The next I am inserting the element E. Okay. So now what will happen? The top value will be increased. So the top value is 1. The next I am inserting the next element H. So now the top is increased. Like this way the top will be increased. So now the top is in this position. And when you are trying to do the pop operation, what will happen? It will delete the value which is denoted by the top. So now the top is here, right? So first 0 will be O will be removed, and the top value is decremented, and now the top position is here. The next L, then what will happen? The top value will be incremented. Now the top is here. Then I am removing L. So what will happen? The top is decremented, so top is here. Then I am removing E. So what will happen? The top value will be decremented. Okay, so like this way the operations will be done in a stack. The next one, queue. So queue is also the linear data structure that follows the particular order in which the operations are performed in first out. Okay, it is also performed in the concept of first in, first out. Okay. So the order in a first in, first out, that is the data elements stored first will be accessed first. But in a stack, the data element which is stored last, that will be accessed first. So that is the difference in the stack and the queue. Okay. So for example, the queue in any queue of consumer for resource where the consumer came first, that person will be served first. Okay. So here the different operations are performed on the queue, like reversing the queue, then reversing the first k element of the queue, and the basic operation performed in the queue are enqueue, dequeue, friend and the rear. So here we are doing the enqueue operation. Enqueue means insert and dequeue means it is a delete. Dequeue means it is delete. Okay. And the insertion, it can take place only at the rear position, and deletion can be done only in the front position. Okay. Then non-linear data structure. Okay. So non-linear data structure means here the elements are not stored in a sequential manner. Okay. Here the elements are not stored in a sequential manner. So the relationship of the adjacency is not maintained between the elements of the non-linear data structure. So the example is tree and the graph. Okay, the example is tree and the graph. So it is a tree. So we are going to see about the tree concept here. So tree is a non-linear data structure. Okay, and as well as it is a hierarchical data structure where the elements in a tree elements are arranged in a tree structure. Okay, in a tree topmost node, so this is the topmost node, it is called as the root. Okay, topmost node is called as the root. Each node contains some data, and data can be any type. Okay, data can be any type. So it consists of central node, structural node and subnode which are connected with the edges. And different tree structure allows quicker and easier access to the data as it is a non-linear data structure. Then next one is a graph. So graph is also a non-linear data structure. It consists of vertices and the edges. Okay, vertices and the edges. So the vertices means the nodes are the vertices. Edges means it is a link which is used to connect the two nodes. Okay, vertices means it is a node, and edges means it is a link which is used to connect the two nodes. So the graph is used to solve the most challenging and complex programming problems, and it has the different terminologies which is a path, degree, then adjacent vertices, connected components and so on. So in upcoming videos we will see it briefly.